hi guys. I hope you understood that video that I showed you. I'm just going to try and highlight everything that about these graphs. They're very important graphs. So I want to just point out that this is called the Maxwell Boltzmann graph. It's also called the kinetic energy profile. Please don't get it confused with the other energy profile graph. You get the other energy profile graph. It's more potential energy, and that's the one where you have that, or you have that. Okay, that shows you your exothermic and endothermic. That's a different energy profile completely. Okay, this is determining exothermic, endothermic, and this is now looking at reactions, okay, and reaction rates. So like they said in the video, the area underneath this graph is equal to the number of molecules, okay, that are reacting, the number of particles. Okay, so I've put it quite simple here. So if we look at number of particles, this means some down here. So there are some with a low energy. Here there's more with a better energy. And here we have nearing a lot with this a bit higher energy. So here's my energy, low, medium, high. Okay, so over here are where particles, the number of particles that have the enough energy in order to react. Anything below the activation energy, remember this could give you a value. This could be 120 kilojoules, all right? This is the activation energy. All right, remember that little bit of energy that each one needs, that kinetic energy, the sufficient amount of kinetic energy so that when they collide, they react. So only that few out of all of them have enough energy to react. Okay, so we want to try and do a number of things. We want to try and maybe move that line up and down, or we want to increase, somehow we want to increase that number. Okay, now remember the areas underneath never change, the size of the area, but the shape of the graph can. Okay, so let's take a look. Temperature. Now, if we increase the temperature, so this is the same one. So here it is, boring old, only these few, okay, have enough energy to react. Now I increase the temperature. Okay, so again, remember, I know we're going through here, but it doesn't really mean anything. So we do get a shift. Okay, so what happens is, can you see here that our peak will shift in that direction, so that you can see where most of our particles have a medium energy now, where here it was between low and medium. So our peak shifts here, it drops down a little bit, but remember that's because our shape changes, but our area can't change. So here, all that part above there has now taken that part of that graph away. So we've kind of moved those over here and spread it there. Now if you take a look here, the number of particles that have enough energy to react, that area has increased. You can see the little blue lines, and there's the red lines. We've got bigger area over there. And so we know that there's going to be an increase in collisions, an increase in kinetic energy, there's an increase in effective collisions, and the rate of the reaction will go faster. Right, so this is what happens when you increase the temperature. The opposite is true. If you decrease the temperature, you're going to get a higher peak over here. And so don't worry about this, drawing this one, okay? And so it's going to shift that way. And look at our small little area under there that now we've decreased the temperature. And most of our particles have low energy. Okay, so please don't worry about drawing the blue one. Rather just keep to the red one. Okay, you can always do the opposite if you need to. Okay, adding a catalyst. Now, if you remember, we said adding a catalyst does something what? Can you remember? It lowers the activation energy. Right, so again, here we have this area under the graph here shows the particles that have enough energy to react. But now I'm lowering the activation energy. So instead of it being quite a high energy, what if I get it over here? I'm now adding a catalyst. So I'm bringing that across. Now look what has happened. I have now increased the number of particles that have enough energy to react. So I didn't change the energy of the particles, but I changed the entrance level of this. Imagine you are applying to university and your marks are just not right, and then they lower the entrance level. Okay, say you needed an A, and then they say no, it's okay, we need a B, and you got a B. That means you can now go to that class. It's the same thing here. These particles didn't increase their energy, but because we lowered the standard, or we lowered the requirements, that means that they could automatically start reacting. Okay, again, our whole point here is to increase the area of the particles so that we get the most particles reacting. Okay, now obviously we get a concentration of particles. Now this doesn't really change the energies in any way. Okay, so this doesn't get affected down here, but this gets affected. And so if we increase our concentration, what we are doing is we are actually increasing our area, complete area, total area. But you can see how the peak is still in the same place. But now instead of, where's my blue? So instead of this only being the area, I now have this whole area. I have more particles that have the correct amount of kinetic energy compared to if I didn't have that. And that is what happens when you add or you increase the concentration. Okay, it's the same if you increase the pressure. If you increase the pressure, you decrease the volume of a container if you have gases. Remember your gas laws from last year. So that's what happens, because you can learn this off by heart, what happens to these graphs. Okay, and what they very often do is they give you a blank graph. So they give you a graph like that, not quite a blank one, but one like that. And then they say, draw over this one to show what happens when there's an increase in temperature. And you actually have to draw it, and then you can explain it that way. Okay, so that is it, and that's all I want you to do for today. Well, in terms of watching a video, so you've seen 2 videos now. I would like you to do exercise 10.1, page 125, and it's only number 3, 5, and 6. Okay, so it's not that much. All right, so please do that for me. Thank you. We can Google Meet if you'd like.